this lesson we have here is parallel lines and transversals. Now let's talk about what parallel lines are first. First, parallel lines are coplanar, so they must be on the same plane. And they never intersect, so that's huge. Coplanar lines that never intersect. And now we have here these skew lines. Skew lines are non-coplanar, so they are not on the same plane. They don't intersect, but they're also not parallel. And I'll show you an example of that in a second here. And here's one of our most important words, transversal. Transversal is a line, could be technically a segment, that intersects two or more lines or segments at different points. Okay? So transversal is a line that intersects two or more lines at different points. So what that looks like is if I have two lines like this right here, this one right here would be your transversal. Okay? Wow, that's really poorly drawn. Anyways, but notice it does say at two different points. So if I draw these two lines that intersect a third line intersecting right there, that would not be considered a transversal because it has to intersect the two lines at different points. So the transversal would look like this because it's crossing here and it's crossing here. Okay. So we have this picture of this piece of cheese just to get some practice and an idea of what each of these looks like. So the first one says name all segments parallel to JP. Again, parallel needs to be on the same plane and never intersect. So here's JP right here. Now JP lies on two planes, JLRP. Now if you look at JLRP, that plane right there, you'll notice that this one's also going straight up and down. So in this case, LR, segment LR, would be parallel to JP. But JP is also on the plane JKQP. So we're looking for a segment that's going straight up and down there, which in this case, KQ would be going straight up and down. So these two segments would be parallel to JP. Now the idea of skew. Skew again means it's not on the same plane and they're not parallel. Not on the same plane, they do not intersect, and they're not parallel. So KL in this case is this segment right here. Sorry. So we're looking for something that's not on the same plane. So KL is a part of KLRQ, that plane, the back plane, and it's part of the top plane, JKL. So any segments that we name cannot be on those two planes. So in this case, one of them that would be skew would be PQ. Notice PQ is not on the same plane. It doesn't intersect KL, and it's definitely not parallel. So PQ would be a valid answer. The other valid answer would be PR. PR also is not on the same plane, it doesn't intersect KL, and it is not parallel to KL. And lastly, we have parallel planes. Parallel planes are just two planes that are parallel. It's kind of self-explanatory. But it says, name a plane parallel to PQR. PQR. So this bottom plane. So in this case, the plane that would be parallel to that, it would be the top plane. So in this case, J, K, L. So understanding parallel meaning it will not intersect. Now parallel planes, obviously, parallel lines are coplanar, but it's impossible for parallel planes to be coplanar because they are their own plane. So let's look at this next example. Here again, keyword, transversal. Notice it's a line that intersects two other lines at two different points. Now when you have a line that's intersecting two other lines at two different points, there are 8 angles that get created. Now with these 8 angles, there are certain, classifications of these angles in regards to their location to each other. And so there's specific names for them. So 1 and 8, angle 1 and 8. Notice angle 1 and 8 are on the outside of lines M and N. So we have lines M and N. Angles 1 and 8 are on the outside, or we say the exterior, of those two lines. But they're also, when you look at your transversal here, angles 1 and 8 are on opposite sides of that transversal. Now, instead of using the word opposite, we use the word alternate. So in this case, angles 1 and 8 are alternate exterior angles. They're on alternate sides of the transversal, exterior of the two lines that the transversal is crossing. Okay. So now 3 and 6 are on alternate sides of that green transversal, but now they're interior of lines M and N. So they're interior of the two lines the transversal is crossing. So these would be alternate interior angles. 1 and 7. Let's think about that. 1 and 7, they are not on alternate sides of the green transversal. They're on the same side. So we can call those same side. And notice 1 and 7 are on the exterior of lines M and N. So these are same side exterior angles. 4 and 6. So you have angles 4, angle 6. So angle 4 and angle 6 are also on the same side of the green transversal, but they are interior. Use a different color there. So they are an interior of lines M and N. So these would be called same side interior angles. And lastly, we have 2 and 6. Now 2 and 6, they're on the same side of the green transversal, but notice one's on the outside, one's on the inside. So whenever you have two angles where they're on the same side of the transversal, but one's on the outside, one's on the inside, we call those corresponding angles. We don't call it same side corresponding, we just call them corresponding angles. Basically, they're in the same position, but on different lines. So notice if you were to only look at angle 6, let's say this wasn't here, line M wasn't there, angle 6 would be in the upper right, I guess you'd call it quadrant, of this diagram with line N. Well, if you did the same thing and you covered up line N, angle 2 would also be in the upper right. So they're in the same position as each other, just on different lines. And again, the easiest way to tell is they are on the same side of the transversal, but one's inside or exterior, one's interior. All right, so now let's go ahead and just get some practice with classifying these. So it says classify the relationship between each pair of angles. So first we have 1 and 5. 1 and 5, if here's our transversal right here, they're on alternate sides of the transversal. They're on alternate sides. And notice that they're on the outside or the exterior. And I'll color these. So they're on the exterior of the green lines, that the two lines that the transversal is crossing. So these are called alternate exterior angles. Sorry. Whoa, my bad. Never mind. All right, now the next one, 6 and 7. So angle 6, angle 7. So notice those are on the same side of the red transversal. Same side. And notice they're in between the green lines, so we would call those interior. So these are same side interior. We'll call them angles here. Should have done that here as well. Let me switch that up really quick. Alternate exterior angles. So for B, 6 and 7, those would be same side interior. Now let's go to 2 and 4. Angles 2 and 4, so you have angle 2, angle 4. So those are on the same side of the transversal, but again, one is exterior, one is interior. So we call those corresponding. All right, corresponding angles. 2 and 6. How about 2 and 6? Angles 2 and angle 6. Those are on alternate sides of the red transversal. Alternate. And notice they're both inside or interior of the green line, so alternate interior angles. All right. 3 and 7. So now we have 3 and 7 here. So 3 and 7, angle 3, angle 7. Those are also going to be alternate interior angles. And I'm going to start abbreviating a little bit here. So alternate interior angles. 5 and 7. So let's switch that up. Let's go to 5 and 7. Angle 5, angle 7. Those are on the same side as the transversal, but one's interior, one's exterior. So that's what we call corresponding. And we have 4 and 8. So angle 4, angle 8. Notice those are on alternate sides of the transversal, but they're on the outside, or what we call exterior. So alternate exterior angles. And lastly, we have 2 and 3. So angles 2, angle 3. Those are going to be same side. And those are interior. What we're going to learn a little bit is what happens when those two green lines are parallel. What happens to the degrees of those? Oh, now we have multiple transversals here. So what do we do here? So like it says right here, what happens if there's more than one transversal? It is important to be able to determine which line is the transversal based on the classification of angles being discussed. Identify the transversal connecting each pair of angles in the diagram below, then classify the relationship between each pair of angles. So here we have 3 and 5. We have angle 3, we have angle 5. Now the key here is figuring out what 3 lines you're talking about, because a transversal is going to cross 2 lines. Well, in our diagram, we have 4 lines. So one of these is useless to each problem. So we have to figure out which one do we not need. Well, my advice is, now if you have some colored pencils, that's always helpful. But I'm going to color the lines that make up the angles. So angle 3 gets created by line H and by line M. Angle 5 is also created by line M, but also line J. So in this case, line K is pointless for problem A. We're not looking at line K at all when we're talking about angles 3 and 5. We're just looking at H and J, making M the transversal. So in this case, if M is the transversal, 3 and 5, notice 3 and 5 are on alternate sides. They're on alternate sides of the transversal, and they're on the exterior of the 2 lines that it's crossing. Alternate exterior angles. How about 2 and 4? So again, what you want to do, I'm going to highlight here. 2 and 4, angle 2 gets created by line H and by line K. Oops, I forgot this set of directions. Identify the transversal. So, for problem A, we said the transversal was line M. So for this one, we have angles 2 and angle 4. Angle 4 gets created by line H and by line M. Now if you notice, it's line H that's playing the role as the transversal, because it's crossing the other 2 blue lines. So now, when you look at 2 and 4, 2 is here, 4 is here. They're on the same side of the transversal. Oh, got to catch myself there. But one's on the interior one's on the exterior. So we call those corresponding angles. So again, when one is inside, one is outside of the two lines that the transversal is crossing, we call those corresponding angles. All right, 5 and 7. And we just keep doing the same thing where you want to be able to figure out what lines are being discussed. So 5 is created by line J and by line M. And angle 7 is also created by line J, but also by line K. So in this case, which line is crossing the two others? That would be line J. So now what we have here is 5 and 7. 5 and 7. Those are both on the same side as the transversal, but again, one inside, one outside. So those would be corresponding angles. Okay? And lastly, angles 1 and 3. Let's take a look at 1 and 3. So angle 1 is created by line H and by line K. Angle 3 is created by line H and line M. So notice on all of these, the one that we keep saying that's creating both, that's on both. So in this case, line H helps create angle 1 and create angle 3. That's going to be our transversal. So line H would be our transversal. If you look at angle 1 and angle 3, it's on alternate sides of the transversal, and they're on the exterior of the two lines that the transversal is crossing. Okay? All right, now, what happens when those two lines that the transversal is crossing are parallel? So that's where we're at now. What happens when they're parallel? So we have here our conditional statement, if, then, right? Conditional statement. If two parallel lines are cut by a transversal, and again, keyword there, parallel, then each pair of corresponding angles are congruent. So in this case, angle 1 and angle 3 are corresponding. Those will always be congruent to each other if those two lines are parallel. Same thing with 8 and 6. Those are going to be congruent. 2 and 4 are going to be congruent. 5 and 7 are going to be congruent. So corresponding angles, those will be congruent to each other if those two lines are parallel. We also have here the alternate exterior angles theorem. If two parallel lines are cut by a transversal, then each pair of alternate interior angles are congruent. So alternate interior, so angle 1 and angle 3 are on alternate sides of your transversal and inside or interior of the two parallel lines. Those will always be congruent. So you know 2 and 4 will be congruent to each other. The next one, same side interior. Now here's where you got to watch out here. Switches it up. Here, it says if you have same side interior angles and those lines are parallel, then these two angles will add up to 180. So angle 1 and angle 2 are not congruent to each other, but they do add up to 180. So that's the key word with same side interior or same side exterior, is that they are supplementary to each other. And they can't be congruent to each other because, notice, one is obtuse, one is acute. The only time those can be congruent to each other is if they were both right angles, because 90 plus 90 is 180. But that's the only time when you're talking about same side interior or same side exterior. And here we have alternate exterior. It says congruent. So alternate, 5 and 7. So on alternate sides of the transversal and they are exterior of the parallel lines, then those guys will always be congruent. Now, you really only need one angle to find all 8 of them if those lines are parallel. So notice we have here that angle 5 is 72 degrees. Well, that will help us find all of the others now. So go ahead and write these down. So, notice that we were given that angle 5 is 72 degrees. angle 5, and there's a whole bunch of reasons we can state here. Let me move these over a little bit. Angle 5 and angle 4 are corresponding angles, and we know that those will always be congruent to each other. So this is corresponding to angle 5. We could say angle 7 is 72 also, because notice these two are vertical to each other. So angle 7 must be 72 because it's vertical to angle 5. That says angle 5, not L5. Five and 2 are alternate exterior angles, and we learned that those are congruent as well. Alternate exterior to angle 5, and there's many different ways to figure this out. We could have said angle 2, and now that we know 7 is 72. We could have said angle 2 and 7 are corresponding. That's why we know it's 72. Or we could have said, since we know angle 4 is 72 degrees, we could say angle 2 is 72 degrees because it's vertical to angle 4. Well, how about the other 4? Well, what did we say? Or let's go with this. Angle 5 and angle 6. Angle 5 and angle 6 form what we call a linear pair. If you connect them, you get this line right here. Well, a linear pair are always supplementary. So if angle 5 is 72, then angle 6 has to be 108 because they have to add up to 180. So we could say it is supplementary to angle 5. And now that we know angle 6, that helps us find all the rest of them. Notice it's going to be one of 2 degree measures when those lines are parallel. Well, angle 8 is vertical to angle 6. And vertical angles are always congruent, so we know that's also 108 because it's vertical to angle 6. We know that angle 3 is corresponding to angle 6, so that has to be 108 because it's corresponding to angle 6. And lastly, we have angle 1. Well, that's vertical to angle 3, so angle 1 we know is 108 because that's vertical to angle 3. So in this case, notice all these angles are one or the other. All the obtuse angles are the same degree measure. All the acute ones are the same degree measure. So if I give you one angle, you technically could know right away it's going to be one of 2 things. So angle 8 is an obtuse angle. So we know the measurement angle 1, the measurement of angle 3, the measurement of angle 6 are all going to match up with angle 8, which means the measurement of angle 2, the measurement of angle 4, the measurement of angle 5, and the measurement of angle 7 are all going to be supplementary to that angle. So in this case, 180 minus 105 gives us 75. So they're all going to be one or the other. Now let's throw a little proof our way. Okay, A is parallel to B. Now when we're dealing with proofs, they leave out the word line. They just that lowercase is we're going to know that that's talking about line A and line B. It says line A is parallel to line B, and then it says line T is a transversal of A and B. So let's get it started. We are given, always write your given first. A is parallel to B. T is a transversal of A and B. That is given. Okay, what can we do from there? We're trying to prove 4 and 5. We're trying to prove that angle 4 and angle 5 are congruent. Now, for this problem, we cannot say, well, they're congruent because they're alternate interior angles, because we're actually trying to prove the alternate interior angles theorem, which means we can use all the other information that we know. We just can't use alternate interior angles because we're trying to prove that. So, what can we do? Well, we have to talk about angle 4 and we have to talk about angle 5 individually. So what we can say, here's an option. We could say that angle 5 and, or we could say the measurement of angle 5 plus the measurement of angle 6 equals 180. Why? Because they're a linear pair. Linear pair. Two angles add up to 180. Okay? To ever make a line, in which 5 and 6, when you connect them, make line A, right? That's always 180 degrees. So we can write that. The measurement of the two angles add up to 180. We can also say, since these are parallel, we know 4 and 6 have to add up to 180 because of there are same side interior angles. So we can say the same side interior angles theorem, which states if two lines are parallel and there's a transversal that cuts through them, then same side interior angles are supplementary or add up to 180. Well, we're almost done here. Notice that these are both equal to 180. This sum and this sum are both equal to 180. Well, if any two things, even if their sums, are equal to the same thing, then we could say they're equal to each other. So we know that angle 4 plus the measurement of angle 6 has to equal the measurement of angle 5 plus the measurement of angle 6. That's what we call the transitive property. We've learned that already. The transitive property. Two things are equal to the same thing, then they're equal to each other. Well, now, what do you see on both sides now? On both sides, we have angle 6 and angle 6. So we can subtract the measurement of angle 6 from both sides, leaving us with the measurement of angle 4 is equal to the measurement of angle 5. We just subtracted that over. And lastly, we want to make sure that we match it to what we're trying to prove. We're trying to prove that the angles are congruent, not just that their measurements are equal. So we could finish off by saying angle 4 is congruent to angle 5, because that's the definition of congruent angles. So this is a way we can prove any one of those theorems. In this case, we prove that alternate interior angles are congruent when those two lines are parallel. Now let's go ahead and throw some algebra at this. Nothing too complex. So the measurement of angle 4 is 2x minus 7. Sorry, 2x minus 17. And it says the measurement of angle 1 is 85. Now, again, if these two lines, R and S, are parallel, then all of these angles are either going to be congruent to each other or supplementary to each other. And the easiest way to figure this out is see if they're acute or obtuse. Angle 1 is definitely acute. Angle 4 is definitely obtuse. So there's no way they're equal to each other, which means we know that they have to add up to 180. If they're not equal to each other, then we know they add up to 180 if those lines are parallel. And now we go ahead and combine like terms. 2x plus 85 minus 17 gives us 68 is equal to 180. Then we can go ahead and subtract the 68 over. So you have 2x is equal to 112. And lastly, divide by 2. X equals 56. It's always good to check your work too. So if you plug 56 back in, you get 112 minus 17, which is 95. And 95 and 85 make 180. For the next one, you have angle 3. If angle 3 is 4y plus 30, and angle 7 is 7y plus 6. Now these are alternate interior angles, so we know those are congruent. But if you forget that they're congruent, again, ask yourself, acute or obtuse? Acute or obtuse? If they're both the same word, both acute, both obtuse, you know they're equal to each other. If you have one and the other, you know they add up to 180. So in this case, 3 is acute, 7 is acute. They're alternate interior angles, so we know that they are equal to each other. So we just subtract the 4y over, subtract the 6, leaving us with 3y is equal to 24. Then we can go ahead and divide by 3, so y is equal to 8. Just to make sure that works, we have the measurement angle 3. If you plug 8 in, you get 32 plus 30, which is 62 degrees. If you plug it into angle 7, you get 56 plus 6, which is 62 degrees. So we just proved that that actually works. All right, almost done here. Last couple. So here, angle 2, you have 4x plus 7, and you have angle 7, which is 5x minus 13. Now, the best thing to do is memorize if they're congruent or obtuse based on their classifications. So in this case, if this is our transversal, they're on alternate sides, they're on the exterior of the parallel lines. Alternate exterior meaning they are congruent to each other. So notice they're both obtuse as well. So you know they have to be equal since they're both obtuse. 5x minus 13 is equal to 4x plus 7. So we subtract 4x, subtract 4x, add the 13, add the 13, which leaves us with 5x minus 4x is 1x, 7 plus 13 is 20. There you go. And last problem. Last problem here, angle 5 is 68 degrees, and angle 3 is 3y minus 2. Now notice these are on the same side as the transversal. They're inside or interior of those parallel lines, which means they are supplementary. And again, if you forget, 3 is obtuse, 5 is acute. So the fact that you said different words means they cannot be equal to each other. So our only other option when those lines are parallel is that they are supplementary, they add up, which means they add up to 180. Which gives us 3y plus 66 is equal to 180. We can go ahead and subtract the 66 over, which gives us 114, meaning that y, when you divide by 3, what is that? That's 38. And if you're in doubt, just plug it in, back in, and we should get, if you did it right, you should get 112 because those add up to 180. So there you go. So this is what you do when you're dealing with transversals and especially crossing parallel lines. And last little thing here, if you ever have two parallel lines and one of the lines is perpendicular, meaning forming right angles, the other one will also be perpendicular to that transversal as well. Just throwing that out there. If A and B are parallel and your transversal is perpendicular to one of the lines, it will be perpendicular to the other one as well. Well, I hope that helps, and I hope you understood.